Welcome to lesson 92 as we explore the idea of percent of change. Now, in the past we've looked at percentage and we've looked at finding percent of a whole. Now we want to understand this concept, percent of change, like how much has an object changed or how much has something grown or decreased based upon a given amount of information. And so to do this, we're going to follow some simple patterns here, and together with some different proportional type boxes, we're able to solve for percent of change. So let's get into this. First of all, it says if we want to have a percent increase, like you were going to say, oh, there was a 40% increase in the number of students from last year compared to this year. How many students is that? That's the kind of information that we're looking at. And so we're going to follow this pattern. It says original number plus the amount of change gives us our new number. And of course, if we were going to go the opposite direction and decrease, we would do something very, very similar. We would find ourselves with the original number, the amount of change. This time we're decreasing, so we're going to subtract, and then we're going to end up with a new number. Let's take a look at what this would look like then in different types of situations. So our problem says the country's population increased by 15% from 1980 to 1990. Sorry, the county. If the population in 1980 was 120,000, what was the population in 1990? And so what we want to do is we want to plug our numbers in to understand what we have and figure out our steps from there once we have this box constructed. So what you're going to do is plug in the amounts. First of all, we have to talk about the original percent. The fact is. That's probably not good English, but this is an English class, is it? That's a poor excuse. Stop talking about English. Let's talk about math. Original. We're going to start with the idea of 100%, and we're going to use 100% because we don't want to say, well, let's just take some of the population. We want all of the population from 1980. We don't want some of the population, so we put the original amount in as 100. And from our information in the paragraph problem, we see that our actual amount is that nice large number right there. Now, from here, we also see that there was an increase, keyword increase, of 15%. So we know 15% is there. And on the left side, we see the idea of change. Right? And at this point, because we have an increase, because that's what our problem says, we're going to throw a plus sign in there to remind ourselves that we want a positive change, that there's an increase in this problem, just so we don't forget. And finally then, we can plug in, we can use the principles we've learned from other types of boxes that we've used in the past to come up with our new percentage, which would be 115%. That's how much bigger it is, 115% larger total when you add those two together. Right? So it's going to be 115% larger than it was here. Okay. From here then, we have two things we don't know. We have what the change of population is, nor do we know what the new population is. But we have lots of techniques to help us solve this. We can set this up in a couple different ways. Now, of course, this says that if the population was this, what was the population in 1990? Right? So these are the steps we're going to take. First, we're going to take our 100% and we're going to take our new population, right, that 115%, because that's what we want to know, the new. So we're going to take, basically we're going to create a proportion of 100 over 115, which is equal to the actual amount of this to our unknown. All right. So from here we're going to cross multiply and then divide by 100. All right, to multiply 115 times 120,000, you're going to come away with an answer of 13,800,000. And then, of course, we want to divide that by 100, which is going to knock off a couple zeros and leave us with this number. So if I translate that, I'll just write the digits first, and then I can plug in the commas where they are appropriate. So 138,000 is the new population in 1990. Right? Now, if it asked, we could actually go and figure out what that change was, and we could solve for C just by subtracting our new from our original to be able to do that. All right, that was an example of an increase. Let's look at an example of a decrease. So here we have this example going. It says the price was reduced by 30%. Right? We're always happy when there's a price reduction on things. So if the sale price was $24.50, what was the original price? Okay, so once again, we're going to set this problem up. The original price, of course, is going to be, once again, 100%. It's 100% of the price. And in this case, we have a reduction of 30. And because it's a reduction, we want to add a symbol to remind us that we're subtracting this time, not adding, when it comes to combining our percentages. And so as we look at this, we have 100 minus 30 to give us our new percentage, which is going to be 70. And so that's what makes it look just a little bit different than what we've done in the past, because we have to subtract that change, not add that change. Now, our problem says that the price, this new price that we came away with, was $24.50. And from there, we have a nice box set up that we can use to help us solve for the original price. So this is our original price. This is our change. Let's solve for R. To solve for R, we're going to set up a proportional type problem. We're going to have 100 over 70, which is equal to, I'm going to use R here. We're just like this. And now I'm going to use the processes that make this easiest, which would be cross multiplication. So I'm going to multiply 100 by this, which is going to give me this number. Because when I multiply it by 100, I move over 2 decimal places. And then I'm going to divide by 70. Divide by 70, just like that. And we can reduce quickly by knocking off our zeros. And so 7 goes into 240. That's going to be just like this, 35 times. Right? So we have this idea. Right? So in terms of money, we would say R equals 35, and we could put those zeros back in just to give us dollars, or because those zeros aren't going to hold much significance, we would just say $35. So as we look at this, what we're looking at really is this idea. Going back to our original idea of these new sentences that talk about how to solve these. And when we go to solve them, the ratio boxes are going to look very, very similar to what they've always looked like, but how we solve for this new depends on what kind of change is taking place. All right, that's enough of me talking. Here's one for you to try as you work with this idea. That's it for lesson 92.